We're starting the YouTube streaming. I'm going to introduce you. Hello, everyone. Welcome to today's seminar. Today we have Dr. Elena Sabbi, who is the chief scientist of the Gemini Observatory. Since joining Gemini, they focused on the observatory's scientific direction, championing initiatives such as the one in the Rubin Gem to maximize the discovery potential of LSST and Gemini partnership. Before joining Gemini, Elena spent over 20 years, or almost 20 years, at the Space Telescope Science Institute, where she worked with a variety of instruments and leading many of them. Their research focuses on star formation, stellar evolution, and young massive clusters. Dr. Sabbi is also a dedicated advocate for accessibility in science, having co-authored innovative ebooks such as Reach for the Stars for individuals with visual, audio, and learning impairments. Thank you, Elena, for accepting our invitation. The floor is yours when you're ready.
Thank you, Anna, for inviting me. I'm very glad to be here with the opportunity to talk about Gemini, the instrument we host, and how you can use the observatory to support your science, and also to promote the Once in a Rubin Gem, the initiative that Anna mentioned before. So the Gemini Observatory is a partnership of 5 countries that includes United States, Canada, Argentina, Brazil, Korea.
Where you're sharing the screen in the notes as well.
Okay. Is it better?
Yes, perfect.
Okay. So I was saying the Gemini Observatory is a partnership of 5 countries that includes United States, Canada, sorry, let me close the door. Argentina, Brazil, and Korea. And we also offer part of our time to our host countries that are our host land that are Hawaii on Mauna Kea and Chile on Cerro Pachon. Our observatory consists of 2 8.1-meter telescopes that allow us to cover the entire sky, and also we have a longitudinal shift. So we are the observatory that allows you to monitor for the longest time possible targets that are roughly in the planar side. And this is the coverage of the sky that you can get from our telescopes. We are the only large aperture observatory that offers you the full coverage of the sky. We also have a very well-established flexible scheduling that guarantees that we can offer always the best observing condition for your proposals. And finally, our schedule was planned to be best adapted for rapid TO response. And in fact, we are able to go on sky between 5 and 10 minutes from the moment you trigger your request for observations. We offer 2 types of target of opportunity observations. One is the standard target of opportunity, and we will observe your target within 1 week from your request. If you have a target that is rapidly fading on sky, you can also ask for a rapid TO response, in which case we are going to be on target within 24 hours from your request. And the programs are set up in advance, so using templates, so that we can make sure that your observations are ready to go as soon as possible. And of course, rapid TO science is a very broad field. It ranges from supernova, gravitational waves counterpart, tidal disruption event, gamma ray bars, but also interstellar visitors like we had recently with 3A Atlas. We offer a variety of optical and near-infrared instruments. We cover both imaging and spectroscopy. And here you can see a schematic summary of the instrument we offer. These are the field of view covered by our imagers. GMOS, it's a visual imager, and it's available both at north and south. And at Gemini South, we also have an infrared imager that is Flamingos 2, and both cover more than 5.5 arc-minutes field of view. We have a broad range of long slit, IFU, multi-object spectrograph that cover low, intermediate, and high resolution. And then I will go through the various instruments in more detail in a moment. We also have a very successful visiting instrument program. We offer SPECOS instrument that allows you to obtain diffraction limited imaging in the optical. We are one of the very few observatories that gives you this type of resolution. And we also have a spectacular, extremely precision radial velocity instrument that is MARUN-X, that is designed to characterize rocky planets around red dwarfs. At Gemini North, we have GMOS North, that is our workhorse instrument. It is an imager, but it can also be used in spectroscopy in long slit, integral field, and multi-object. We have one of the two speckle imagers that is Alopeke, that operates in two filters contemporary. And then we have MARUN-X, that is our high resolution spectrograph for extremely precision radial velocities. And this is like Alopeke, a visiting instrument. We also have infrared capabilities that include GNIRIS. It can be used in long slit, cross disperse spectroscopy, and two integral IFU units. iGreens2 is a high-resolution spectrograph with resolving power 45,000 that covers simultaneously the H and K band. And then GNIRIS can be used in AO mode, in high-resolution mode, with our AO system Altair. At Gemini South, we have the GMOS counterpart. We have the speckled counterpart Zorro. And our high-resolution spectrograph is GHOST. And finally, we have in the infrared Flamingos 2, which is a very versatile imager and spectrograph that can be used both in long slit and multi-object spectroscopy. GMOS, both at north and south, covers the filters U, G, R, I, and Z. We have a field of view of 5.5 times 5.5 arc-minutes, while the IFUs have the field of view of 5 times 7 and 5 times 3.5 arc-seconds. It can be used, as I mentioned before, both in long slit and multi-object spectroscopy. And this is And this is an example of how the long slit, the multi-slit can be distributed over the field of view. These slits are pre-cut, so you have to prepare a mask, and then the mask will be cut at the observatory. The wavelength coverage goes from 0.36 to 1.3 microns. And it is a very versatile instrument that has been used for solar system characterization of small bodies and comets, astrophysical transient, AGN characterization, stellar population, and high redshift galaxies. GNIRIS is our mid-infrared, it's our infrared instrument at Gemini North. It goes from 0.8 to 5.4 micron, and it can be used both in long slit and cross-disperse mode spectroscopy. It has a very wide range of different resolutions from 1200 to 18,000. And it can also be used in IFU mode with AO capabilities. Again, it's a very versatile instrument from astrophysical transient to the nucleosynthesis and the study of AGN, stellar mass losses, high redshift galaxy evolution. This is an example of the spectra that you can get with the GNIRIS. And this is how GENIRIs perform with Altair, both with the low resolution IFU and the high resolution IFU that was recommissioned very recently. And you can see that really you can, because we have such a large aperture telescope, you can get very exquisite details in the observations, considering these are IFU observations, not imaging observations. Still at Gemini North, as a spectrograph, we also offer iGreens 2. This is a copy of the iGreens instrument that we had at Gemini South. iGreens 2 has been provided by Korea, one of our partners. It has a resolution 45,000, and it can cover at the same time the H and the K band. So the spectra goes from 1.45 to 2.45 microns. And it's really a spectacular instrument if you're interested in the chemical characterization of various objects in star formation, stellar metallicity, exoplanets, supernova ejecta, and so on. Moving to Gemini South, in addition to GMOS, we have Flamingos 2. It is an imager and a spectrograph. In imaging, we have a very large field of view of 6.1 arc minutes, and the wavelength coverage ranges from 2.9 to 2.4 microns with different setups. The resolution varies from 300 to 4500, and it can also be used in multi-object spectroscopy by cutting different slits. So because of this variety of setups, it has been used in a variety of scientific cases. One of the most recent upgrades at Gemini South is GHOST. This is a spectacular fiber-fed shell optical spectrograph that covers simultaneously the wavelength range from 0.36 to 0.95 microns. It can be used both in single target or two target mode. In single target, the spectroscopic resolution is more than 75,000, sorry. And in the two target modes, the spectroscopic resolution is 50,000. It's a very sensitive instrument, and so in 1 hour, we can reach signal to noise 30 for an object of magnitude 17. These are examples of the spectra that you can get with the GMOS, and because of the exquisite resolving powers, it's really a powerful tool if you want to understand the chemical composition of stars, of galaxies, the atmosphere of a transient exoplanet, or the characteristic of the stars that is hosting an exoplanet. And then if you are interested in the properties of binary stars, definitely it's one of the most powerful instruments that we can find at Gemini South, in the South. As I mentioned before, we have speckled instruments. They are SORO and Alopeke. Alopeke is at Gemini North, SORO it's at Gemini South, and both word means fox. This is the spectacular resolution that you can get with speckled mode on an 8-meter telescope compared to what you can do with other facilities. And the best counterpart is what you can do with spherics in the K-band. But again, we do this in the optical. And what you see here is the center of 30 Doradus. For a long time, people thought that this star here, A1, was a binary, and then for the first time, SORO was able to find a companion, and then the companion was also identified with spherics. There are several characterizations. In general, these instruments are used to confirm or to confirm that targets that are found in exoplanet surveys are not contaminants from background stars and other characterization. The Maroon X is our extreme precision radial velocity stars. Last year, it played a major contribution in confirming that the Barnard stars indeed host a planetary system. This was something that was proposed over and over again, but was never confirmed. And following 3 years of monitoring with repeated observations, Maroon X and Espresso confirmed that indeed there are 4 exoplanets orbiting around the Barnard stars. Maroon X operate between 0.5 and 0.9 microns, with the resolution, with resolving power 82 to 88,000. And it can measure velocities, radial velocities, much better than 1 meter per second. It has been used to study binary system, confirm the presence of exoplanet, and derive their masses and radii, and also to characterize the atmosphere of these exoplanets. These are the instruments that are currently on our telescopes, but we are also waiting for new instrumentation coming soon. Starting from the end of 2027, we are going to get Scorpio, which is an imager and a spectrograph. We are going to have Girmos, and we will also have GPI2 back. Scorpio is an 8-channel imager. It simultaneously gets all 8 band images from the G band to the K band. The field of view is 3 by 3 arc minutes. It can also be used in long slit mode with resolution 4000, and it covers continuously the wavelength from 0.3 to 2.35 microns. It was built, it was designed with a time domain in mind, because you can simultaneously characterize the spectral energy distribution of these objects across all the optical and near-infrared spectrum. These are the performances of the expected performances of Scorpio compared to LSST. LSST is in yellow here, and Scorpio is in red. The continuous line are the performances for the imager mode, and the integration time is 1 hour both for LSST and Scorpio. And the dashed line on the top are the performances that Scorpio will have in 1 hour of observations in spectroscopy. One thing that I would like to highlight is that all the bands can be configured independently, so that you never saturate and you get the optimal signal to noise in the readout of the various channels. At Gemini North, we are upgrading our AO system. We are going to replace Altair with GNAO. This was financed by the NSF GEMA Award, and it will operate in 2 modes. We have a Y-field mode that provides GLAO correction, and so we have improved over the natural seeing over a field of view of 2 arc minutes. But we also have a narrow field mode that provides diffraction limited performances in a K-band over a field of view of 20 times 20 arc second. GNAO will feed primarily Girmos. Girmos is an imager and IFU spectrograph that is designed and built by our Canadian partners. It can operate in 2 modes. We have a wide field MOAO mode that covers about 2 arc minutes. And in this mode, you can distribute 4 IFU within the circle highlighted here in yellow. And so you can cherry pick your favorite target, and the target will have this extreme resolution. We also can operate the telescope in a tile mode where all the IFUs are concentrated together to create a square, and you can map a larger areas. The instrument offers 2 resolving types, 2 resolution, 3000 and 8000. And it also, there is an imager that covers the wavelength, the band from the Y to the K band, and then there are assorted filters there. From a spectroscopic point of view, the instrument covers from 1 to 2.4 microns. Again, it's a very flexible instrument. It was built to look at the kinematic and merger of galaxies at cosmic noon. It's perfectly tailored for this science, but it is also a fantastic tool if you're interested in characterizing the evolution of high redshift galaxies, for example, or tracking the distribution of dark matter in lensed galaxies. Because of its infrared capabilities, it's fantastic if you want to study star-forming regions in the local group and characterize the kinematic of star clusters and their chemistry. And just to give you an idea of its performances, this is the comparison of GIRMOS highlighted by this blue rectangle compared to NIRSPEC, NIRCam, and other instruments that operated at similar wavelengths. Finally, we are going to welcome back on Gemini GPI in its upgraded version GPI 2. GPI 2 will be hosted at Gemini North. GPI was at Gemini South. This is a coronagraph with extreme AO capabilities. What you see here on the left is an example of a planetary system that was monitored with the GPI. The AO capabilities allows to operate the instrument between 0 and 14 magnitudes, and you get a stray ratio of 0.9 for stars that are brighter than 12 in H-band. The contrast ratio is expected to be up to 10 to the 7 with a separation between 0.2 and 1 arc second. And the wavelength range is again from 0.9 to 2.4 microns. It can be used both in coronagraphy and direct imaging and in IFU spectroscopy, and also it supports polarimetry observations. The instrument was built thinking of the characterization of lower mass planets around the young stars and higher mass planets around older stars, to really characterize the closer 4 to 10 AO orbit, where you expect to find the gas giants like Jupiter and Saturn. However, it is also been used to study transitional disks and to characterize AGN jets, and it has been used to study some of the some of the moons around the gaseous giants. If you want to apply for time at Gemini, and I hope that by seeing the variety of instruments that we can offer, you will be interested in applying for time at Gemini, we have different flavors. We have regular programs that are offered every semester. They are reviewed by the national TAC of the partner country. And this is a program that is used for routine programs. We largely encourage now Q observing mode, but we can also support classical and visitor priority visitor mode. If you have very ambitious programs that require a large number of hours or repeated monitoring, we offer what are called the large and long programs. The calls happen once per year, and they can cover up to 3 years of observations. At the moment, only Canada and US participate to this initiative, which means that the PI must have an affiliation with Canada and US, but every COI from every country are welcome for this program. And then we have the fast turnaround. These are calls that are released every month. They are reviewed by the other proposers, and they are designed for programs that need a very rapid follow-up. Within 3 months from your approval, we will get the observations. The observations are done only in queue, and this don't need to be a high impact or a very urgent program. It's just something that needs to be done now to finish a paper because you have an exciting case. It's a very flexible program. We have also a director discretionary time. Submissions are welcome anytime, and they are reviewed by the chief scientist and a small committee. It's for special opportunities, and the observations are done either in queue or priority visitors. And finally, we have the poor weather proposal. If you have a bright target that can be observed under any condition, you just submit your observation at any time, and the head of science operation will schedule your observations when we have a moment that meets your conditions. And it is something that we really welcome, because otherwise, if the weather, if we don't have bad weather, poor weather targets, we might have to take the telescope idle for a while. At Gemini, most of our programs, depending on the partners, but our programs usually are submitted through the dual anonymous review process. And this was introduced to guarantee that we minimize biases in granting time. We do not offer time just because you are a famous astronomer. We offer you time because your science is exciting. To reduce the data on Gemini, we have, all observations collected by Gemini are stored in our archive. The raw data are collected for all the instruments. Reduced data are available for GOST, GMOS long slit, iGreens 2, Soren Alopeke. Observations for Maroon X are reduced by the visitor instrument team. Currently, the format of these observations is not compatible with our archive, and so they are sent directly to the PI. But if there is a target that was observed with Maroon X and you are interested in getting the reduced data, please contact us and we will send it to you if the data are not covered by proprietary time. For all the other instruments that are not Maroon X and Soren Alupeke, you can reduce the data yourself. We have a Python-based pipeline that is named Dragons, and it provides data reduction for GMOS in imaging and long slit, Generis long slit and cross-disperse mode, GHOST, Flamingos 2 imaging and long slit, and for Generis and Flamingos 2, we also have the telluric line correction implemented. The pipeline is actively developed to cover more modern instruments, and so we will continue to bring new instruments, new observing modes in our pipeline. But in the meantime, for the modes that are not covered with Dragons, you can still reduce your data using Gemini IRAF. And then if you have, we have a number of tutorials on our web pages, especially you can look at the NGOs web pages. There are information on how to reduce the data and how to apply for Gemini time, but also you can contact our help desk for any issue, and we will support you with data process, with planning the observations, and so on. Gemini is aggressively moving forward to support time domain astronomy. Because of this, we are upgrading our tools for planning the observations and also to interact with the various components that leads your data from observations to a paper. And this is done through the Gemini Observing Planning Tools, which is the tools that you use to submit your proposals and plan your observation, but it is also the tools that we are going to use to operate a telescope in the future. This tool will become available in September, so starting the next call for proposal, we will use this new tool instead of the PIT and the OT. We are also bringing online GOATS, which is a browser-based user interface that is planned to link together the alert brokers, if you're interested, for example, in the science that Rubin LSST is now starting to perform. If you want to plan your observations, if you want to explore the archive, and if you want to reduce the data on real time, everything can be done through the GOAT brokers. That allows you also to make sure that you have the best and latest version of the various tools that need to collaborate in this complex ecosystem to go from planning your observations to writing your paper. I would like to conclude my presentation talking about the ones in a Rubin Gem. Rubin is a starting operation. We've already got a number of alerts from Rubin, and it's ramping up in the number of alerts that we're going to deliver. We expect to have more than 1 million alerts per night. And we are sharing the same sky of Rubin with Gemini South. The two telescopes are physically located on the same mountain, Cerro Pachon. So they really see the same sky. And we want to make sure that you consider us as one of the primary telescopes for the follow-up of the science that LSST is going to enable. to make sure that we can respond to the most unexpected, confusing discoveries that LSST will do, and that we respond fast to that, we are offering a 120-hour DD initiative that is distributed over 3 years for now. And we want to create a framework for rapid response that really capture the early evolution of the LSST unknown unknowns. The observations will have no proprietary time, and we have letter, an email subscription that you can join to be kept informed on the target that we are going to follow. You can propose a target through this initiative, and you can get more information about how to participate to this initiative by going on our website, and you can use the QR code that you see here. We are bringing in this new mode because the typical DD requests that are reviewed by our working group and that are approved requires several days of interaction, even if it is a rapid target between us reviewing the proposal, sending, confirming that the proposal can be executed, send it back to you, and you having to redesign the observation. You're probably going to lose something of the order of 1 week before you can be on sky. And instead, with this new infrastructure, we hope that we can really respond within 1 to 2 days from your request. And we have 4 science categories for this proposal. We have the solar system, the galactic field, extragalactic field, and then fringe cases that are not easily characterized in one of these other boxes. The requests are submitted via a Google form that is available on our website, and we observe a variety of modes from GMOS imaging and spectroscopy to infrared imaging and spectroscopy, and also ghost high-resolution data. We offer also IFU observations, and we have different setup for the long slit. However, they are not always available on sky, and so it is we recommend that you verify that your observing requests are indeed supported for that night. The requests are reviewed by a small committee of experts that were elected by the participants of our mailing list. And if you register on our mailing list, you will receive an email every time that we go on sky as part of the Rubin Gem, and also when the data are observations are completed and are archived in the Gemini archive, are stored in the Gemini archive. And I'll stop here, and I will be happy. Sorry, Mimi. I will be happy to take your questions. Thank you.
Let's thank Elena. Thank you for the nice talk. Do we have questions? Online? We have one on YouTube.
The person hasn't typed yet.
Okay. So meanwhile, I'll ask one about the timeline for Gyrmos and Scorpio to be on the telescope, and when we can ask them with goats. Use Pete.
Okay, so Scorpio is currently planned for second half of 2027. We should have the commissioning and the share risk call for proposal. So people will be allowed to request observations with the caveat that because we are still testing the instrument, we might have hiccups, and so we may not be able to complete your observations. But usually we are good, and we actually get very good data. We are also going to have a system verification call for the users where we will welcome project, and then we will ask you to use the data that you collect to give us feedback on how the instrument is performing, the documentation, what can we do to improve your experience with the instrument. Girmos is expected for sometimes in 2028, 2029. And yes, we're all very excited at the idea of having Girmos capabilities at Gemini North. Before Girmos, we are going to get GPI2 back at Gemini North sometimes next year, I guess. Yes, 2027 is next year now.
Cool. Do we have the question?
Not yet.
Rogério,
So,
just let me.
Thanks
Do
for
you-
the very nice.
Do you hear first?
Can you hear?
Yes.
So thanks for the very nice talk. Regarding Scorpio, so I saw you will try to manage the exposure times independently per band, because that is actually the huge problem of X-Shooter, for instance, in not working. So could you give, please, a little bit more details on how this will be done?
Yeah, so every single channel will have its own independent readout mode. And so if you need to do a long integration time on, well, the integration time the final integration time will be determined by the channel that requires the longest observations, but you can break the individual readouts in different lengths. And so you may end up having 5 readouts in H band and 10 in the I band, simply because you don't want to saturate in that band. And the same will be true also for the spectroscopy.
Okay, so that is actually the point, because the near infrared is going to change very fast in the sky. So if you are not able to have a sky position, so it's going to be difficult to do a good
Right.
data.
So in the infrared, we are going to have individual readouts. Then you can, if you want, you can even realign them. And right, if you really are trying to do something that is extreme precision, you can even reject some of the readout because they are not as good as the weather, as the seeing is changing during your observations. But you will have the individual readout that you can combine with the pipeline automatically.
Okay, perfect.
Cool. More questions? Otherwise, I have one. Did anyone apply for the once in a Rubin Gem in the first and only so far stream of alerts?
We were not. So we are still actually finalizing the last steps. And so we did not get any requests yet. But we didn't even get any DD requests in the last stream of alerts. We did a test in the last stream of alerts. Yeah. So we wanted to check that we can respond complete. So that was before the official going online, but we wanted to test the end-to-end system with LSST triggering, the brokers being ready to select the target, and us going on sky with GPP and GOAT and the data reduction. And we were very successful. We observed a couple of supernovae, both at Gemini North and Gemini South. And we repeated the observations the night after, just to make sure that indeed it was not a lucky shot. We were really ready to operate.
I have a question. Anna.
Yes.
Okay, you may.
You mentioned that the archive has GMOS long slit reduced data. So is it going back to the old data or starting now? What is the plan?
We are starting now, and we are going to process everything. It will take some time to digest everything, but we are processing everything.
Excellent. Thank you.
This is very cool. And I have another question, and people will have any. My question is related to you had in the once in a Rubin Gem, like the only the Antares broker attached to the figure. Is that just the figure, or will we be able to plug in other brokers?
No, it is just a figure. You can choose the broker that you like, but I was doing a self-promotion.
Okay, if we have no more questions, let's thank Elena again. And we hope our data is observed at this mine when the Altair is working or when it gets substituted, because I've had 6 failures proposal in the last 3 years, and it's very, very sad.
I'm so sorry. We fixed a lot of the problems that we were having. So I'll keep my fingers crossed for your observation.
Thank you. Bye-bye.
Bye-bye.
Here's everyone.